What is Lean Six Sigma? I came home from teaching a class with my black belt, and my son asked, "Papa, what is it you do exactly?" I answered, "I teach and coach people on how to use Lean Six Sigma." "Yeah, but what does that mean? I don't understand." Now, I could have told him to Google it, but then he would have had knowledge, but not understanding. So I offered to teach him Lean Six Sigma. Yeah, that was his reaction too. That's when I realized I had to get better at explaining Lean Six Sigma. What do you think of when I say Lean Six Sigma? Toyota production system, statistics, or it's all Greek to me? Well, hopefully I can make it as easy as 1, 2, 3, 4, 5. Let's start with who influenced the creation of Lean Six Sigma we use today. Let's start with one of the first production processes. Adam Smith in 1776 studied how workers took all day to produce one pin. He identified 18 steps required to make the pin and set up a process with 10 workers. This division of labor allowed the 10 workers to produce 48,000 pins in one day. In the early 1900s, Frederick Winslow Taylor started measuring cycle times and process flows, becoming one of the first industrial engineers. He is seen as the father of the efficiency movement, sometimes called Taylorism, after him. But he was often criticized for his views on how workers should not think, but just do. Needless to say, he was not popular with the unions at the time. Henry Ford, about the same time, started using process flow to build the Model T on an assembly line. But as Ford said, any customer can have a car painted any color he wants, so long as it is black. It took until World War II for Taiichi Ohno to come up with a more flexible system of manufacturing flow. Ohno implemented a system focused on eliminating the 7 sources of waste. This effort became the Toyota production system, the basic systems of Lean. Ohno worked with Shigo Shingo, who developed a system using small lots with quick changeover tools, using his method of a single-minute exchange of dies, or SMED. He also contributed to the Kanban pull system of inventory management. Just before World War II in the US, statistics use also started in manufacturing at Western Electric. On May 6, 1924, an engineer at Western Electric, Walter Schuhart, sent a memo about his development of statistical control charts. This was the birth of using statistics to control and solve manufacturing issues. Later inspired Edward Deming to use these same tools in Japan after World War II, including creating the Schuhart cycle of plan, do, check, act, one of the early parts of what now is Six Sigma. When Schuhart spread statistical process control across Western Electric, one of his first people he trained was an engineer named Joseph Juran. Juran also took his knowledge to Japan after World War II, like Deming, helping the Japanese to improve their quality, and was one of the first to use the Pareto principle to solve quality problems by understanding 80% of a problem is caused by only 20% of the causes. During this same time, Juran encouraged his friend Dorian Shannon to start consulting as well in the US, using these same statistical tools and ideas to solve problems. Shannon combined additional statistical tools from Schuhart, Juran, Tukey, Fisher, and Weibel to create his problem-solving methodology. Now, how did all of these things lead to the development of Six Sigma? Well, as the Japanese products and qualities improved, thanks to Deming and Juran, Motorola was suffering in the US. They couldn't compete with the improved Japanese products or services in the early 1980s. So Motorola brought Dorian Shannon in to consult during the early 80s, and he influenced an engineer named Bill Smith. Now, Smith developed a systematic statistical approach to solving customer satisfaction problems, becoming the father of Six Sigma. Now, it's unclear when Lean and Six Sigma merged, but it started during the 80s and 90s. The Lean Six Sigma concept was first published in 2001 in the book Leaning into Six Sigma. This book was a guide for manufacturing managers on how to reduce cycle times with Lean and reduce defects using Six Sigma. Kind of sounds like a process for providing your customers with what they want. Remember, I said it's as easy as 1, 2, 3, 4, 5, and it is. Now, the number one thing is to focus on is always improving customer satisfaction. Simple enough. The two things you need are the twin pillars of Lean and Six Sigma. Lean being the focus on reducing waste or what the customer is not willing to pay for, and give them what they do want, better products, faster, and in a color other than black. And how do they do this? Using the tools of the Toyota production system. Six Sigma is a data-driven problem-solving method using the DMAIC flow. What's DMAIC? It's an expansion of the Shewhart cycle of plan, do, check, act. You define the problem, measure the process, analyze the process, improve the process, and then control the process. But before you combine Lean and Six Sigma, you need to do three things. First, you need to identify a leader to drive the cultural change through your company. Jack Welch is a great example of this from GE, with how he made Six Sigma a part of the GE culture. Second, implement Lean Six Sigma across the entire organization, not just in a few small areas. Again, GE is a great example. Welch made a Lean Six Sigma black belt a requirement to be a manager at every level across all the businesses within GE. But remember, the third thing, don't take too big of a bite at first. Try solving your problems with Lean Six Sigma only if you're following the Pareto principle of focusing on the 20% causing 80% of your problems. Once you have your leader and have implemented Lean Six Sigma across your entire organization and focused on the right projects using the Pareto principle, you need to focus on the 4 keys to Lean Six Sigma success. First, excel at providing your customer the best quality when they want it. By removing your process waste with Lean tools and reducing your process variation, causing quality issues with Six Sigma. Second, developing the Toyota production system. Taiichi Ohno realized teamwork between operators and management was key to improving a process. Contrary to the followers of Taylorism, focus your team by training them in Lean Six Sigmas at all levels throughout the organization. Third, base your decisions on the data and facts you collect, not on hunches and gut feelings. Fourth, make Lean Six Sigma part of your daily life at home and at work. How? With a Lean tool, 5S. Sort your area by getting rid of items you seldom use. Straighten your things by keeping them where they are used the most. Shine and clean your home and keep everything in its place. Standardize the processes you follow with daily task list. And perhaps the hardest part, sustain your improvements at home and at work. Now, you're ready to achieve success with Lean Six Sigma. So maybe it is actually as easy as 1, 2, 3, 4, 5, 6 Sigma. Do you feel like you can answer the question, what is Lean Six Sigma? Why does my definition matter? Let me tell you a little bit about me. After watching Neil Armstrong step onto the moon while sitting on my grandpa's knee, I wanted to be an astronaut. I studied astronomy, geology, and physics in high school, and I was on my way to space. I started checking into the requirements for being an astronaut when I realized I'd been lied to. I'd been told, whatever you set your mind to, work hard and you can reach it. But there it was in black and white. Maximum height, 6 foot, 1 inches tall. At 6'4", I couldn't reach my goal. I couldn't be 3 inches shorter. So I decided to become an engineer to design taller spaceships. I discovered my new mission, solving problems by building taller spaceships. And I've been solving problems ever since. Now, I haven't given up on reaching space. I still have Elon Musk and Richard Branson working on this for me. But until then, I look forward to teaching you Lean Six Sigma so you can solve your problems and build your taller spaceship.